So we will have Martin again, together with Timothy Ravier, and they will look at some security issues.
Okay, so thank you again for being here. Okay, 2 presentations in a row. Okay, let's do it. Back when we started writing the book, the guidebook for new developers, I don't know who asked me to talk a little more about security, because I started talking about SLNX inside the book. So someone asked me to do a presentation for XDC, and here I am with Timothy Ravier. We did the same school, so both of us are security engineers. We are not Linux graphics stack developers. I work personally on power management, so I don't really work on the graphic pipeline. So all the interaction with memory and sharing. So we had to learn all this to do the presentation. So if you spot anything that is wrong, well, just say us. But I think it's going to be not that bad. Shouldn't be. So the presentation is mostly done for Linux, very focused on Linux. And we are interested in desktop and mobile UI security. So feel free to interrupt us. It's going to be a long presentation. It may be a bit, let's say, it may be a bit mean to some people, but we are not trying to be trolls. We really want to improve on the security, and so we are just proposing stuff. We've worked on desktop security before, and we made an operating system with some researchers. So we kind of have an experience, and so that's why we feel like we can talk about this. So first, we'll talk about what the user expects from as a security properties, and how the X server is able to, well, how it fails to be able to provide them. Then we'll talk about Wayland and maybe what we could do to improve Wayland to be more secure. And finally, we'll talk about the very hard part about hardware and driver security. So we'll see. So, you know, in security, we always talk about confidentiality, integrity, and availability. So it's going to be our outline for first the X server, and then Western, or not Western, well, Wayland compositors. So let's start with a use case, or something that could be happening in some very worst case scenario. So for confidentiality, a user could be shopping online, and so he or she has to write a credit card number at some point. But if there is a keylogger installed on the computer, well, you kind of get the credit card number straight away. It's very simple to get it. Another possibility would be to take screenshots periodically in order to, just if Firefox is the application that is on top of the others, then we should take screenshots every second to get the credit card number in its entirety. So in the end, if this information is sent through the network, which is not a privileged thing to do, well, the credit card number is stolen. So what the user actually expects is that applications shouldn't be able to spy on the others. So they shouldn't be able to spy input events or output buffers. And the only way to communicate between applications using the graphics server should be copy-paste or drag-and-drop. So this would make e-shopping safer on the system side, because it's done on the network side. So what about X11? Well, it grants full access to whoever can read the magic cookie. So basically, it means that any application run by a user can access all the other applications run by this user. So there are only isolation between users. And so the problem is that application cannot be trusted anymore. They grew in size, we have way more, let's say viruses, but I don't like the term. Well, people can execute code that shouldn't be executed. So apps cannot be trusted for that, and apps can be launched behind the user's back. The user is not aware when an application is run. It can be run on the background. So there is a problem here. So no confidentiality, unfortunately. As for integrity, well, again, let's imagine we have a user visiting a website, like the bank website, his bank website. So, well, he's pretty smart. He or she is pretty smart. The user checks that the website is accessed in HTTPS and it's the right domain. It can check the certificate, and then, well, you have to trust and, well, use the website as you should. But what happens if, well, the user is actually on the wrong website, a fake one, like for phishing, but the Firefox address bar has been tampered with another application that will just overwrite the well, the address bar with the right, the faked website. This is something that can actually happen with DRI1, because applications are able to render stuff outside the screen, outside their window. So that could happen, and this is not something we want. So the user's expectation is that what is displayed by the application is what the application actually drew, and the events that got received by the application are the events that have been done by the user. So like pressing a key or moving the mouse. So yeah, the application should never be able to alter other applications' output buffer or input events. And so, as I said, with the X server, GRI1 allow applications to render outside their window, and we can be a virtual keyboard, so we can inject new events when we introduce ourselves like a virtual keyboard. So integrity is not good. So what about availability? This one was a bit difficult. We had to think about what can be done to, well, boost the availability of the graphics server. So the users are expecting that their computer are doing multitasking. So a single application shouldn't be able to stop the whole computer from working. It should be self-contained. An application should only, well, block itself if that's, if the application wants to, but it shouldn't be able to block any other application. So with X11, well, an application can act as a screen locker. So you cannot bypass the application. So what can you do? Well, you're stuck. You cannot use your computer anymore. And a virtual keyboard can send some, well, they may kill an application using the XF86 clear grab. It was a security hole that was introduced in Xserver 1.11. It was found by a friend of us, actually. It was nice. So yeah, so an application can kill other applications. So this is not what we want. Oh yeah, and we can kill, well, send a kill signal, of course, but we are just talking about the X server here. So yeah, availability is not very good. So I'll leave the mic to Timothée to talk about the hardening method that we can do on X, and then he'll talk about Western and Wayland.
Okay, thanks, Martin. So hi, I'm Tim. And so we've seen that there are a lot of troubles, a lot of problems with X globally, and in terms of security, so integrity, confidentiality, availability. And during our projects and other projects, try to find ways to mitigate those problems and to bring more secure desktops. So first, I'm going to talk about specifics. X server specific things that have been introduced to bring more security. Sorry, I have troubles with the mic. So first is about XACE. It's an extension to X which had access controls into X, and you can plug it using some things like SR-Linux. So to make it XSR-Linux, like an X11 hardware, where you can check access to a lot of things like drag and drop. Doors and application has access to the server, to pointers, to the mouse, and such. So, like we say, it's mostly per feature access controls, but it's like you have access or you don't have access. You cannot have steps in it or modularity or granularity. It's quite global, and thus it's mostly deactivated in most ordinate system like Red Hat Enterprise Linux and Fedora, because you don't have confined users on these systems. The general model of Xorg, which is to trust applications that are launched by the user, goes in conflicts with this, as you, well, that's why they deactivated it, because you just have to trust applications. So, well, you can't just block applications from accessing the server, from using the servers. So one of the ways that has been put forward to confine applications between the X server is to use Xfer, which is a sandbox, like sandbox in X. You can launch applications into another X server inside X, which will be separated from the main X, so you won't access subball input buffers and such. The problem is, as always with sandbox services, is when you want to share information between sandbox, it's complicated and such, and you have to bring new code and new things into the party. So, well, two projects have tried to bring more security to the X server, and they choose two different ways of doing it. Mostly, the first one, kubes, which might be known by some of you, is used virtualizations mostly to bring confinement to separate applications in different X servers. And the other one is PigaOS, which use the SR-Linux and XSR-Linux. The goal here is always the same: is to confine applications, separate application, and force them to use separate means of communications to control which applications can access input buffers of others and such. So first, let's talk a bit about kubes and its design. The goal is to group applications into domains that have the same levels of security. Like you go into Firefox, you want to access the web, so it's a low security virtual machines. And you go to Firefox, you got your mails and such, but you don't have your private mails, your corporate mails, which are located in other virtual machines, and with another X server. So you've got separated X servers into each one of the virtual machines, and separate applications in each of them. So it uses Xen to provide virtual machines, and as always, to communicate between virtual machines, you need a daemon, you need a way of communication, to have drag and drop, to have copy paste, and file copy paste and such. So you have a daemon which is located in one particular Xen virtual machine, the DOM0, and well, it helps interact with other virtual machines. So here are two screenshots. I'm not sure you can see them correctly. They detail one of the feature with kubes, which is you can see from the title bar, the color of the title bar, in which domain the application is. So for example, here you have Firefox, which is the red domain, which is a low confidentiality domain, for example. And here you got another screen asking for sparse words, which is in green, sorry. So you can trust this one, but maybe you don't trust this one really. So it lets the users choose which one is important for him, which one is really high confidentiality, which one is lower, which one might have been tampered with, and which one is okay. On the other side, you've got let's extract from the sys-tray when you can see the network things and the nodes, which are in two different colors too.
So the user really knows in what domain or what the application is running. So this is good for him. He can separate tasks.
Yep. So well, the goal here is always to have different tasks separated into different virtual machines, and to keep files separated, to keep private mails from the internet and such. Well, you could use other things like they use virtual machines, they use Xen, but you could use other things such as LXC or C groups and such to bring this kind of separations to being. You could use KeyVM and such, but the problem is always like you have to use a lot of virtual machines, a lot of less separation, and this brings problems for the system. Like of course, it's slow when you use a lot of virtual machines on a desktop computer. On a laptop, even more, it's slow. It's not feasible on mobile. You have to have hardware acceleration mostly to use it properly. You don't have acceleration like graphic acceleration, and limited power management. Xen, this is one of the problems with Xen. And you're not even sure that Xen is capable of separating virtual machines. So yeah, there might be ways to access buffers and such between VMs in Xen. So another project, the one we worked on, was Piga OS, which goal, as always, is to bring a secure desktop, a secure server, a secure X server, a secure application desktop. And here again, we want to confine applications into domain. So we choose, well, the project choose to use SLNX to confine applications, and so to use XSLNX to confine applications on the X front. With SLNX, you can add labels to applications, to processes, and confine them between the domain and prevent them from accessing resources in the system, from accessing passwords and such, even if they are root, for example. However, with SLNX, you have a policy, a global policy that you must build and enforce, which is well quite long to set up for some time, and you with this policy, you have access to a lot of features with XACE, the extensions, and the whole X servers, but you still don't have all the features you need to bring full servers, full secure desktop. So we had to implement another daemon to switch between activities. That's why it's called Piga Systrans, and you have a way of switching activity. Maybe you are into the tax context. You wanna check your taxes on the internet, your bank on the internet, but then you go on a video on YouTube. You don't want to have the Firefox. Maybe you don't want things to. You want previous applications which were run in the bank context to have access on your things on YouTube, or the other way, maybe. So you have to create separations and context switching between those stacks. So here's an example of PGAOS, on which you can see an example domain, which is email, where you've got all your related emails. That's the context. You've got every application is aware of the context in which it is. So here it's email. So it shows only email related to global email. Yeah, and no Firefox. Well, and OpenOffice is also aware of the fact that we're running in the email context, so it shows only documents that have been created or that can be tagged with the email context.
This is done by SLNX, it's not modified by...
There is a second microphone.
Oh yeah, right. So this separation here is done by SLNX. It's not. We didn't modify OpenOffice to actually show only the files that were created in this activity. So it's just that we changed the SLNX policy at runtime, so as we can. Well, if this file has been tagged as being part of the activity email, then you can access it while the system is in the email activity. Otherwise, you won't see it. So that's the same here for mails, but we had to modify close mail to do that. So we only see the mails that should belong to the email domain. So this one is like a general domain, and the next one is e-shopping. So I'm sorry for the snapshot. I couldn't get the English version of it. So in this domain, e-shopping, we only see stuff that are well, from eBay, because we said that mails from eBay should be the only one accessible in this domain. And we see here that for the same directory, we don't see the old file, test.odt, but now we see ebay.odt. So, yeah, that's it.
So that's an example of confinement and activity switching between the two. You're still using the X server and no virtual machine. So yeah, we know we don't need virtual machine to do this. We can have acceleration and such like graphic acceleration, compositors and such. And we dynamically adjust the context based on what the user is doing. Like you go into such website, you can go into the context corresponding to the website. Well, you do have power management. We don't use virtual machines and such. But the problem is that you require a Linux, the full policy and such, and it's quite long to set up. So we are going to go about Wayland and Western and how they tried to fix things in Wayland and Western, and which problems are still remaining, which might need attention to bring more security stuff. So first, we're gonna switch from the CIA triad things to something more focused on features. Here, it's about input security and how it's done on Wayland and Western. So first, on input confidentiality, Western, the compositor mostly knows where applications are on the screen, so they are able to direct input exactly to which applications require them, to which application is affected by input. So you don't have broadcasting like in X, you don't receive all events. It's okay, it's just the only applications affected by the event which is informed. And this basically defeats keyloggers, which obviously. So you can just have one application, receive all inputs. Inputs is received only by the application affected by input on the screen. So this is for input confidentiality, which is good, but on the integrity side, it's okay too. You've got restrictions to access the two main devices which are used for input, which is /dev/input, which are restricted access. So for now, you cannot forge input and give it to Wayland Weston, mostly. So it's okay. You cannot forge input like you've got like virtual keyboards. The input an application receives is obviously only coming from real input device, so from the user. So this, yeah, sure, got questions or remarks? Yeah, that's a question about, that's the next thing about virtual keyboards. So,
there's a bunch of security features to not supporting all the functionality that X supports today, and that when this functionality is added, we'll have to make sure that we do it in a secure fashion.
exactly, that's the point of this talk. Like from the concept, we do have security from the basis, from the concept. So that's good, and we will add exceptions for particular applications, such as virtual keyboards. And we'll talk about this a little bit later. So on the input sides, we're good with Wayland Weston. On the output sides, on buffer sides, on screen buffers, we do have some problems about confidentiality first and integrity. Because Weston uses GEM to share output buffers between the application and between the compositor, and this raises some concerns, as you have to use this GEM graphical memory manager to pass buffers between application and Wayland and Weston, but buffers are referenced only by 30-bit integers, and which can be guessed, which means other applications can access other GEM buffers easily with Wayland Weston. So correct me if we're wrong here, but I think that's it. Well, so this is really a problem. Where's right?
My question is this really an issue on Wayland or is more of an issue on Weston regarding
Actually,
the GEM?
It's a Wayland design problem, because it's Wayland which enforces GEM buffers to share between application and Weston. So it's both. Well, it's a problem in GEM first, because you can just share buffers with anybody. Just need to have access to the 30-bit integer.
Okay, but if you implement a compositor which are currently not using GEM handles, then you can.
It's not a Wayland compositor then.
No, that's not true.
Sorry.
Yeah,
Okay.
so Wayland doesn't specify that we should use GEM. It's just the way it's implemented right now with Weston. And if we are going to move to DM above, it's going to be secure. So it's not a Wayland problem. It's not in the protocol. It's just that currently with Weston, this is a problem, and we wanted people to be aware of that. That's it. Any other questions? Okay.
Sorry, it's the fact that we have to use, that we use, okay. Well, so DM above and such might be good if we choose it. On availability, finally in Wayland Weston, we don't have screen locking yet. So that's another security feature which came from the fact that we don't have features, which will be fixed. But that's a good time to think about it and think about how we should do it right. It's obvious that application shouldn't create a competitor, shouldn't deny access to other application. Well, if you have any idea on this side, well, it's common basic knowledge, like this got to work, but well. Okay. So let's talk about exceptions, like we said about virtual keyboards. Like we have a way for we need to have a way for to add accessibility and such to the compositor. Virtual keyboards need to send input to the compositor. So this is a tricky part, like you don't want to have application forge input, forge user input and such. So maybe those applications should be included in compositors so that they are trusted. Oh, I see Martin. Well, so on this side, if those applications are included in the compositor, you trust the compositor, so you trust input coming from it. So you trust input coming from those virtual keyboards. You trust that this input is really coming from a trusted application, which is included in compositor. Sorry. The problem is you want to trust the processes. Yeah.
Yeah, I'm just asking what do you mean by could be included in the compositor, because one of the issues we face with virtual keyboard is that you need one for English and all Latin languages. You need one for Pidgin. You need one Pinyin. Sorry, Pidgin is something else. You need one for Tamil, all the Indian languages, and so on and so forth. So right now on the desktop, I don't actually know how many virtual keyboards we have implemented. It's well above 20, I think. So I don't even know how many we ship in Fedora, but there are several of them, and it seems like every half a year someone starts a new one. So that's the if you want to actually include virtual keyboards in the compositor, that's a never-ending task because there's just too many languages out there.
Okay, maybe we should refine on the include part. The thing is, as you have to trust the applications which is sending input to WLAN. So the compositor, to the compositor, sorry. So the compositors just shouldn't trust any application like we do today with virtual keyboards. The fact that, for example, the compositor is launching the application, the virtual keyboard, and it trusts only these applications, is something we can do. I'm not sure.
So, yeah, one solution could be just to let the compositor run the application and give special rights to this application. And in this case, not every application could be a virtual keyboard, only the one that has been launched by the compositor. And then it can, as it launched it, the compositor could just grant special rights to this application, and it would be good, I guess. If you have any concerns about this, I would love to hear about them.
So one of the things we have with input methods at the moment is that you can actually switch the frameworks behind it. At least that's in the X stack. So let's just say you speak Japanese and Chinese, some dialects anyway. Depending on what language you've selected, the framework that's actually used in the background emulating the events changes as well. It's not unsolvable. It's just as long as you just need to know this from the start, because X has 20 years of history. That's how it ended up. But I'm pretty sure the guys working on input methods need to be well aware of that ahead of time.
Yeah, that's a valid concern. I think it's not, as you said, it's not unsolvable. It just needs to be worked on. But yeah.
Yeah, I don't disagree with the approach. I think it's the right approach. It needs to be advertised.
Good.
Okay, so that's about visual keyboards. I think, it's quite a zip. Okay. About screenshot applications, which is another problem because that's a feature we do not have yet in Western WLAN, and that will cause problems, confidentiality problems. A screenshot application has to have access to the wall buffer, the wall thing that is printed on the screen. So obviously this breaks confidentiality because you can see card numbers where the user is typing on his keyboard and such. So you have, just like visual keyboards, you need a way to tell this application is okay, it can take screenshots. I think this is trusted, and we can let him go and take as many screenshots as he wants. So, maybe just like visual keyboards, they should be launched by the compositor, so you know that this application is trusted. they could be limited and such. Well, we have to define a way to specify which applications the compositor will launch, which he will choose to launch, which one he will choose to accept or to trust. And finally, another problem is about global shortcuts. Like most media players use some shortcuts to access features like play next song, pause music, and such. And most of the time, they are not visible on the screen, so they do not receive events directly. They are in the sys-tray or hidden, completely hidden. But they want to have access to those key key combos, which you could use to pause music, for example. So we need another way for applications to register specific key events to the compositor and to make sure that those events are sent to those applications which are not shown on the screen. And this brings another problems. Let's say an application just register every keystroke on the computer, and this just makes another keylogger. So we need a way to specify which applications has access to which key, or which key can it register, or how many key can it register, how much. And it's quite a general problem here, because most of the time the user will change the key combo, so the user will have the possibility to specify itself which key combos are registered. So well, we got no idea on this one. If you have any,
there is a you can take the easy way out, which is a lot more code to write by using the semantic approach. So instead of an application saying I want to register for Control-C to do something, you have a global registry where an application registers I want to be notified for undo, I want to be notified for a cancel event and all that, and then the compositor handles which key shortcut actually controls the undo event, which has the benefit that it can make it globally accessible over all applications. It's always the same shortcut that does the same action. Has the disadvantage that you're going to run into all the conflicts about which action is which, and so on and so forth. It's not a solved problem. Especially because you run into issues with Wacom tablets are currently being used for shortcuts as well. So people want to press the third button down on the pad to do undo, and that's a common use case scenario here. So this is a huge task. The GTK guys are currently working on something similar like that, so it might be worth talking to them.
Okay. This is an excellent idea about the fact that we match action and we do not match keys exactly, so the application does not really have access to keys, but certainly to actions, so we can control which actions an application has access to, and even in the case which it requires all actions, it's not that bad, but well, we'll think about it. So again, screen locking, it's exactly the same thing as always. We need a way to specify which application well, it's another feature that is missing that we need to implement, and which should be done right. Well, so this should be part of the compositor too. Like screen locking applications are much smaller. They do not require a lot of stuff to work. They do not need 20 different versions of keyboards and such. So maybe this should be completely implemented in the compositor, so we would have no problems. Okay, I think we have to move on. If you have any idea on this one, well, we'll see later. So here's another proposals for Wayland, for Western and such. In order to control exactly what applications are doing in Wayland Western, we could add access controls, just like XACE extensions. We could add, at some places in the code, we could add hooks to control which applications can do to others, which applications can talk to Wayland, can do things with Wayland and such, if you can receive inputs and such. this, well, this should be implemented as a separated library, so we will be able to use it globally on any compositor and such. But well, it's a complicated, it's a delicate matter. If you have any question about this, we'll talk about it later.
Yeah, because in games there could be many keys and the people keep on changing the keys. So how are you going to handle that part?
I'm not sure that's a problem, because when you play games, you just play games full screen. So it's okay, that's the application which is on front, and it receives all inputs events, and that's... Yeah, that's about the screen locking part, but... Okay. Well, that's another problem. You need a way to... That's application... Well...
If I can just well put the game inside the multitask let's say screen. I mean, it's normal. The game, well, if the key sequence is not very common, like Alt Tab, well, what's the problem? I mean, if games decided to do that, I think it's dumb for them to do that. So we shouldn't continue doing allowing them to do that. This is stupid. I mean, if the game is crashed or kind of crashed, you cannot move or exit it unless you go to a TTY and do kill. Is it logical? No, it isn't. So I think this is not a problem.
What about the performance?
Oh.
Performance issues also, because you are keep on checking the events, key events in the your container or in the compositor, right? So will it affect the performance also?
We are not really, I would say, we are not graphics developers, so we just give general guidelines that should be implemented, and if it's possible. So will it slow things down? I don't think so, but I may be wrong. Yeah, so we don't have an answer for that, but I don't think so. Okay.
Well, another part of the security features we could implement is about rootless Western and rootless compositor, which is although a problems with which is actually here with X, like we don't have rootless X. What's blocking us from doing it is like input management, like we need access to dev input and such, which is only accessible by root. Dynamic output management. If you plug a mouse, you have to be able to access this mouse. Output buffer, you have to send buffers to the screen to show things. So there is one way we could implement such a thing, which is a separate program which is run only, which is really small, and which is run with full root privileges, and which should pass descriptors to the main Xorg servers. But well, this is another architecture modification which we could talk later if you.
That's important. So yeah, the point would be to have a minimal program that will just open the files we want, like dev input, and then pass the file descriptor to the actual X server or Western, so as Western and the X server would not run as root. And we can pass file descriptors either by forking or just by using Unix sockets. We can do that. So I don't know if it's sufficient. I don't really know the problem with rootless X, but we just thought about that, and maybe it will solve the problem. Like if you have a minimal base that is just run as root, and then everything else is run as a user, then it's way better than what we have. Okay, so I'll continue and talk about the hardware and driver security. So, what should be the requirement of a good driver and hardware security? Well, it shouldn't allow a Unix user to get some more privileged. So like going from a user, going root. It's not acceptable. We shouldn't be able to access other applications' data. So that's, again, confidentiality or integrity, right? Access to other buffers than the one that you actually allocated and are supposed to access. So the current status. Well, we have good access control to the RAM and VRAM by the CPU. But on the other hand, from the GPU, we can access, well, VRAM, depending on the GPU. You can access the whole VRAM and maybe also the whole RAM. That's the case for Tegra. You can access everything, Tegra 2. You can access everything from shaders or GPU copy engines. This is really bad. Yeah, is the NVIDIA guy here yet? Okay. So, yeah, nice to meet you. So yeah, the NVIDIA driver allows unprivileged users to access all the almost all the registers of the card as being non-root. So this is not good. So yeah, so what can we do about this? Well, we are already exposing a secure API to the user land in the open source drivers. This is good. We hide the hardware. We don't allow people to well, access it mostly. I may be wrong, but so yeah, we need to expose a sane API that isolate GPU users, and this API should be the only way to access the GPU. So no regs should be accessible from the user space. I mean, or maybe just from root. Anyway, we also need to restrict the GPU accesses to the RAM. So the goal is to deny access to the GPU, for instance, to kernel internal structures. So that's what happened with the latest NVIDIA vulnerability. Well, not the attack. So they moved the VGA window in order to access the kernel structures and modify them in order to gain root access. That's nasty. The other way for the GPU to access the RAM usually is the AGP aperture, except on Tegra. On SOCs, usually they don't have that, of course. And then we can have the IOMMU to do access control. Well, it really depends on the device we are talking about, so this slide is not very descriptive. It will be too long otherwise. So we need to isolate GPU users into separate virtual memory, not virtual machines. So we want to restrict the GPU users into its own data abstraction, well, memory address space. So this is the most secure solution, so as an application cannot read the other application's data. The problem is that it increases the context switching delay. This is a problem with DRI too, because we are doing a lot of context switches, and with Qt 5, where all applications are going to have a OpenGL context, it's going to be a real problem, at least for us, because on Nouveau context switching, it takes a lot of time. And this is something that could be used by AMD. I'm not sure if it's Southern Island Plus, because I think they didn't have the hardware context before. I'm not sure. I wanted to check, but I forgot. Well, at least Intel couldn't do that until maybe Sandy Bridge or the one after. Not all. The point is, not all hardware can do that. Having virtual memory for every GPU context. Sorry, I'm rushing through the slide because we're late. So the other solution to isolate GPU users is to use common submission validation. This is done by Radeon and Intel. So it's good for context switching delay, better than what we have in Nouveau. But we have higher CPU usage in kernel space because we have to check all the commands that are sent to the GPU. But it can be used by any driver on any card, as far as I can tell. Timothy?
Do you have any notion or quantitative knowledge of how that kind of data checking compares to the actual computation time that the GPU requires to go through a command list?
I don't, but maybe Jérôme can know that.
So
yeah, it's dependent. It depends.
completely depends on the use case. Some application have a very small command stream for what they're doing. Some application might actually do a lot of command stream for the rendering they're doing. So the overhead of command stream checking is kind of very, very different from one use case to the others. And it can go quite up. If I remember correctly, the worst case I've seen and I was trying to do an application for the worst case, was something like 10% of the CPU time of the application was inside command stream checking.
How about compared to overall clock time? You know, real time of getting the graphics operations done.
I don't remember any figure, but
I mean, who cares about using up a bunch of CPU time? The question is, does it slow down the rendering?
no, it does not slow down the render because we have bigger issue inside the stack right now. So.
What else? Oh yeah, this one. So I don't know if you've realized that, but sometimes when you reboot, you see on the screen old content that is displayed. That's because when a buffer is deallocated, well, it's not erased, it's not zeroed. So it may be a problem, a confidentiality problem, because if an application just requested, well, buffers and just read them and then requested more buffers, it could basically read the whole VRAM that has not been allocated at the moment. So, well, it can be a real problem depending on the on how often an application changes its buffer or reallocates buffers. So yeah, it's a big confidentiality problem, but the problem is that if we want to zero every buffer that we've allocated, it takes a lot of time. So what can we do about that? I mean, it's good for confidentiality and the output is prettier. But on the other hand, yeah, there is a high performance hit on some memory intensive applications. So maybe a solution would be to zero unused buffer when idle and using the GPU to do that, not the CPU. So we can do that, at least on NVIDIA cards, but yeah. Oh, Lucas.
Even if the GPU is doing this work, you don't really want to do this work on embedded platforms or anything that has not that much bandwidth. So if you're really constrained on bandwidth, it's not even who does the work or if you have some free resources otherwise, but the bandwidth hit is immense with zeroing buffers on allocation or even on idle. So.
Yeah, I guess it's a feature that we could enable or disable, well, as the user wants, because some user want security, some just don't care. I mean, it's normal. We shouldn't lower performance just because some people want security. Everything should be, well, not everything, but yeah, it should be optional.
So why not just zero buffers if the first use is not a fill?
The first use is not a?
So if the first use of the buffer is to write some content into it, you don't need to zero it.
Well, but you know that the application is going to do that. You shouldn't trust that. I mean, if the application just wants to read the whole VRAM, well, it can just ask for buffers and read them, and you will, the application will be able to read everything that had been written before and deallocated but not zeroed.
So like in the X case, you could, you know, the first time the pix map's used, you can keep a flag that the pix map hasn't been used, and the first time you either attach a DRI to drawable or do a read pix, you know.
There are many ways to get it,
so, I mean,
to get more performance. That's for sure.
Right.
But I try to make it simple and easy to understand, not put all the ways to make it fast. But yeah, I agree. There are many ways, like when we can give a buffer that has already had been allocated to this channel ID to, well, channel ID again. So this way you don't have to zero this buffer anymore because it was part of the application before, so you don't, there's no confidentiality problem here. So there are many ways to make it faster, but yeah, I didn't try to put everything here. Okay. Then, oh, is it the last slide? Good. So the limits to per GPU user isolation, basically per application isolation. This is what we want. We still have some problem with compositors because the compositors get all the buffers. Well, if the compositor is, I would say, well, a plugin of the compositor wants to access everything, it may be able to do it. So what can we do about it? About this? So, well, we don't really know. It's just an idea, but when possible, the plugins shouldn't be able to access the buffers or access the input, and we should make it hard for plugins to access the buffers. And one solution could be to do address space layout randomization inside the VM, so the application virtual memory, GPU virtual memory. And when the application is accessing a buffer that is, well, that has not an address that is not allocated for a BO, a buffer, then just kill the application. So it's like a segfault, but for the GPU. And this would increase security in the case where an application would want to read the whole VM. Yeah, at the moment we don't crash the application if it accesses an address that is not mapped. We just put a comment in the kernel logs and that's it. Well, do you have any question about this? I really rushed into the slide, so I'm sorry. Okay. So thank you for listening. Oh yeah, there's a conclusion. Good. So again, the goals were to make it possible to implement activities and provide secure isolation between applications. And in the end, yeah, create something that like Cubes OS and Pega OS, but without all the overhead of having a Linux policy that is quite difficult to maintain, or using virtualization. I mean, it's a big fail for us that we need to create new machines to separate activities. It's not, yeah. We should do something better than that. We should allow the user to decide what he wants, like per application isolation, maybe more performance. It should be simple, but it should be configurable. And we need to be ready for GPU shared clusters. So we need to isolate GPU applications, because otherwise, well, you know, in some public clusters, if a company puts some work, I don't know, for high-speed trading, well, they have some information they want to keep secret, and so it's good to isolate the applications very well. I don't know how it's done in NVIDIA. I don't know if it's secure or not, but... And then, yeah, the current state, we have no confidentiality integrity between applications run by the same user in Xorg, in X, so the Linux graphics stack should... yeah, it makes it possible to spy on users. And needed work, increase isolation between GPU users. It's simple, right? Okay. Thank you for listening. And, well, if you have questions again, but we are low on time. Okay.
I have a small, quick question or remark. Is that when most of the applications are not ready to get errors from denied requests. I don't know if the situation improved with recent GTK, but when we played with XICE in the past, basically each application just got an X error, xlib event, and GTK was ignoring this event, and the default handler just quits the application. So this is completely user unfriendly, and it doesn't work in practice to try to restrict access for a given application to a given kind of resource in the X server. And if you are going to do more fine-grained access control, it's really important that application have a very good strategy to handle all the errors that are going to come back whenever a normal user is trying something that's forbidden.
Yeah, I fully agree on that. And I mean, we don't want actually to fix X. It's not possible. There are too many applications that are written, and we cannot do anything about it. We cannot ask people to rewrite them. But with Wayland being new, we can hope that we can provide general guidelines and something that is easy to understand. I mean, the Wayland documentation is quite short, so this is good. And it would be great to have some security added to it, and so as application can be secure from day one, or at least they know that they should check this, and not just well, XACE was introduced after after the fact that X11 was released. So I mean, people didn't know it. So yeah, I mean, with Wayland we can do something now, and this is good. That's what we want to do.
I have a question about CubesOS. So what I understand is they separate processes by having them run on different virtual machines. It means one process cannot contact the other process because it's in a different kernel system, but they still share the same X server, right? I mean, how is the drawing done? They all appear on the same screen. Is it like CubesOS takes screenshots and draws the screenshots, or is it like X server forwarding, X forwarding?
I'm not sure. Do you know that? Okay.
So with Cubes, you've got one main server which is in DOM 0, the main Xen domain, which is the one which is the most privileged on the computer, and which controls other virtual machines. In each virtual machine, you've got another X server which retrieves input events from the main Xen server, the main X server, which is in DOM 0. So the one in DOM 0 chooses which applications should receive inputs, which other virtual machines should receive inputs, and distributes inputs.
Okay.
Is it clear?
Does it drop features? Like, what happens if you run GIMP? Can you make a screenshot?
The only screenshot you can make are the ones inside virtual domains, or if the screenshot applications is related to the main Xen X server, it can basically screenshot anything.
Okay. So it's basically a lot of different X servers, and
some
communication between them.
Like NX, maybe there's not like X forwarding, because with X forwarding you could access the host server, which you probably don't want. So it's probably some layer in between. That's why it's probably even slower. Yeah, like nesting a server so the events can't go outside. Okay.
Well, yeah, we're not experts in that. We didn't really work on it. As long when we saw it was using virtual machines, for us it was okay. There's no need to work on this. I mean, it's not feasible. It's not the right way to do it. So.
It's not doable for consumer laptop. You can expect a user to launch virtual machines for each application and specifically choose on which domain each application should be. User just want to launch Firefox and see it coming and make sure that no other application can access Firefox. So that's basically a no-no for Cubes.
Okay.
Well, thank you.